Hey, everybody, welcome back to your Dawn of Autonomy podcast. I can't believe it's the end of January already. We've dedicated this entire month to the theme of new tech, and it's been sponsored by AI Bot. So we wanted to thank them. And we have an incredible show for you today with TruWeather Solutions, who's kicking off actually a 4-part quarterly series today with Dr. Chris Zarzar from TruWeather, as well as Basil from AeroX. They're partners. So great to have you both on the show.
Great to be here. Thank you for having us.
Absolutely. So I'm going to start with Basil. You know, so many people in the drone industry, also advanced air mobility industries, know you, Basil. But for those that don't know you, can you give a little bit of background about yourself?
Yeah, great. Thanks again for having me here. So I wear a couple different hats now, but my interest in advanced air mobility in UAS started when I worked for the North Carolina Department of Transportation. And back in 2013, the state was really looking at how can they capitalize on this growth in UAS or drones, but there are also some concerns around privacy and safety. And so in my role at NCDOT, I was in a group within the Division of Aviation, and we just were called now to the legislature to help them understand if there was any appropriate laws to put in place. And so some laws were passed in 2013 and 14, which really set the stage for my career and trajectory. And the legislature needed a group now within state government to help lead this initiative. And I was really in the right place at the right time and volunteered for that. And so over the years since then, I helped lead the UAS integration pilot program for North Carolina, which included some really exciting firsts. The first routine medical package delivery operation that was in Raleigh, North Carolina, first statewide UAS response to a national disaster. That was Hurricane Florence in 2018. And we just really kind of built on that momentum. And so by the end of the integration pilot program, there were over 5 routine drone delivery operations, including folks like Zipline, Valancy, Causey Aviation, and Flytruck. So it was a really exciting time. And so since then, I've now stepped away from the state government role and started a nonprofit that's focused on, again, advancing this industry around building a UAS traffic management system. And so that's exciting. We'll talk more about that. And then I also wear a hat where we've started a venture fund that's making investments in this space as well. And so we can talk about that more as well. But just really excited about this opportunity to chat with you and really passionate about this industry as a whole.
Well, thank you for that. And by the way, Basil, I remember I met you, gosh, so many years ago. I forget even where, but I remember you were on a stage. And I remember afterwards, I ran up to you and gave you my card. And I said, you know, I want to meet you. I want to talk more about you. And I've been watching your work and what North Carolina as a state has been doing in large part due to your efforts. So that's awesome. And by the way, speaking of, engagement, everybody, we see you out there. We know we've got a lot of people on AVSI's YouTube today, so thank you. Be sure to jump in the chat. Tell us where you're from. Give us positive words of encouragement. Ask these guys your questions because we've got 2 incredible experts, and that's a great segue now to talk to Dr. Chris Zarzar. So, Chris, you're a little bit newer to TruWeather Solutions, and by the way, everybody, TruWeather has been such a friend to P3 Tech Consulting, to this show, to everything that we do. It's the first time Chris has been on the show. We usually have Don Bershoff, the CEO. So, Chris, tell us a little bit about yourself.
Yeah, no, folks know Don very well, but I'm pretty new to the game here. But for me, actually, the drone experience started back in 2015 as well with my dissertation. And so my background is Earth and Atmospheric Sciences, but during my dissertation, we were trying to find out why some areas were flooding. And the best way to do it was to do some mapping with the drones. And so down in Louisiana, we were flying drones all across the coastal estuaries to figure out what's going on when it rains and causes these floods in this town that none of the models are picking up. And so we needed that live data to figure out what was happening. And so then, that led to a university career for me for the last 5 years or so. And I was doing some work doing actual weather modeling, but really local scale weather modeling, trying to understand how cities and landscapes change precipitation patterns and change rainfall rates and those kind of questions. But towards the end of my career in the university side, I started talking with Don Birchoff, in fact, and I was having trouble because I did not have the local scale weather observations I needed to both enhance my model and also to verify my model. And so from there, Don and I got to talking. I started learning about this TruWeather mission, and I couldn't step away from it. I had to be part of it because that is the problem we're trying to solve. We're trying to understand what's happening here and now with real data and leverage that real data to enhance models, make better forecasts, and make better decision support tools. And so I latched onto that mission. I love it. And that's what we're doing here today with TruWeather.
Yeah, it's an incredible and very important mission. Don is a cult of personality, and it's really hard not to get swept up into his passion and enthusiasm. And honestly, just one of the thought leaders in this space that is out there, just literally rocking the world. And speaking of rock stars, we know you both are rock stars as well. We've got Randy Pilland. I don't know if I'm saying your name right, Randy, but his comment there in the chat is these guys are rock stars, and Randy is from Elon University. So thank you for that,
Hey, Randy.
very kind comment, and keep them coming, guys and gals out there. We love that stuff. So keep them coming. So Chris, you alluded to it a little bit, your kind of your connection to TruWeather and how you became a part of it. And obviously TruWeather started well before you stepped into your current role. Can you tell us a little bit about the origin story? Because Don is out there, I'll use the term proselytizing, right? About low altitude weather and the data gap. And tell us a little bit about that origin story. And then Basil, I'm going to go to you and ask you about why you created AeroX.
Definitely. So TruWeather itself started by Don Birchoff and based on 40 years of military service in the Air Force, understanding what's going on when it comes to the weather challenges and how they affect operations for the Air Force itself. And so in that experience, it was really understanding what are the challenges, what are the opportunities, how can we improve decisions with the current information we have, but then a realization that the current system just won't service the drone and eVTOL industry like we need. And so the current system has been remarkable for commercial aviation and these high altitude flights. But if you talk to any helicopter pilot, any general aviation pilot who are flying at the lower altitudes, they'll let you know that there's just not enough information. They need more data to make better decisions and to feel more confident in what's going on in that lower part of the atmosphere and the low altitude that they're flying at. And so Don Birchoff and TruWeather saw this opportunity and seized upon it, that this need to get more weather sensors and new diverse weather sensor data out there. But the challenge is you have to disrupt the market. You have to disrupt the status quo. You have to disrupt the current policy and start to drive for new policy to enable and allow for those new diverse and diversified sensor technologies to be utilized by the aviation industry. And so that's what TruWeather has been doing. It's been one, guiding the policy in the direction that it needs to go to enable safer low altitude airspace. And it's been identifying and establishing the partnerships to enable these novel new technologies that will diversify and help us to better understand what's happening here in the low parts of the altitude, here in the low parts of the atmosphere where we're going to fly.
That's awesome. And by the way, Chris, you just created a new tagline for TruWeather, free consulting here, weather disruptors. I love that because, that's exactly what you guys have been doing and continue to do. And this idea of partnership and the series that you're doing over the course of this year, and of course, Basil being one of those partners is a great example of that. So Basil, tell us about AeroX.
You mentioned, how did I start AeroX? And really, it's a we that started AeroX. Shout out to Randy, who you mentioned with Elon University. We're really fortunate in North Carolina to have this great community. Randy hosts an annual drone day at Elon University, which is really exciting, and Chris and I have attended that. We appreciate his support there. But really, there's a great community here. And so when I was working with NCDOT and working with partners that wanted to expand drone delivery or fly beyond visual line of sight, I recognized that we really needed maybe another organization that was a nonprofit that could take some funding and build that. a state organization just has its limitations. For those of us, Don, we've been in government, we understand, unfortunately, there's bureaucracy. And so we, a few folks from the Winston-Salem area who were experts and who were leaders, they were CEOs of large companies, some were aerospace manufacturing companies, some were other computer science companies. They had a passion for aviation, and they said, Basil, we'll work with you together, and let's start this nonprofit. So we started that in 2021, and one of our first goals was to, again, get funding to build out a system that can enable beyond visual line of sight. So we went to our state legislature and kind of told the story about the rich history of aviation in North Carolina, starting with the Wright brothers, and we said, and right now we are in this probably the biggest change in aviation. Instead of the jet engine, which took us really long distances, connected us overseas, now it's getting really more in the community at this low altitude airspace. And how can we utilize that? And so we said, we need to build a system to capitalize on this and bring companies to North Carolina. So they wrote us a check for $5 million, and that's what we've been using to build, again, this system. So we're really lucky. We thank our state legislature and their investment, and really excited to work with industry partners like TruWeather to kind of make this vision come to life.
Well, you're right. I mean, if you build it, they will come. And so you were very smart to go to legislature and say, we need money to do this to get out in front. Not every state is doing that, Basil, as you know. And North Carolina has been at the tip of the spear, as you mentioned, the IPP, the Integration Pilot Program, and now Beyond, and all the amazing companies involved in that, including now TruWeather as well. By the way, everybody, I'm going to have Mike drop, Mike, our Oz in the background here, Mike Peel, our producer, drop this article I wrote for AUVSI eBrief, the business solutions about TruWeather's advanced technologies to keep aviation flying. So that'll give you an idea of some of the sensors that are out there. By the way, we also did, we being Mike and myself as part of our full crew brand, did a product demo with TruWeather and Don about explaining the sensor network that he's attempting to blanket the nation with. And so I commend that to your attention. You can check that out on the Don Zoldi YouTube, and I believe TruWeather's YouTube channel as well. But Chris, I think that's a good kind of point to make now is, let's talk a little bit about the technologies that you guys are bringing to bear to fill these data gaps for low altitude weather, and specifically the ones that you and Basil together decided to start employing in North Carolina.
Yep. Well, the first aspect of that is the capability to integrate the sensors. And so the first thing that we've developed is V360, which is that vertical, as we like to put, the vertical MRI of the atmosphere. And the way you do that is you make sure that you can incorporate a diverse set of sensors, data sets, etc. And so that includes a variety of different types of weather sensors, and they all have different data formats. And so it's doing this interpretation of that. It's dealing with the different types of weather model data and integrating that into a very easy to digest and interpret interface. And that's what V360 does. Now, the technologies we're talking about deploying and working with AeroX on is continuing to work on and deploy this V360 technology to accelerate the adoption of these novel data sets, but then also these different types of sensors that we can deploy. And so these range from sensors like your cost-effective sensors to things that are up there with the current ASOS deployed. But you don't need an ASOS everywhere. What you need is information that can help you to understand the current conditions. And that doesn't require the top tier, most expensive thing out there. It requires something that can get you what you need at the right time when you need it. And so we're talking about a variety of more cost-effective sensors, mid-tier sensors, and some of the high-ranging sensors. And so with AeroX, what we do is we're identifying what are those strategic deployments. And that's key about this network of networks concept, where we do blanket the nation in new weather observation technology. It's a strategic and targeted approach to those deployments so that we can help those operations where they're happening and not randomly put them out there. That's not what we're doing. We're very targeted, very strategic about those deployments, and we work with folks like AeroX to identify where, when, and how those need to be deployed.
Yeah, absolutely. I mean, there's no one size fits all solution. I mean, you've been studying this even as part of your, as far back as your dissertation, you know, that different structures, different locations, especially over water, right, will have different requirements and needs and different weather patterns. So Basil, in North Carolina, and you've been so involved in the UAS and advanced air mobility sectors there, what are kind of the gaps specifically, or what were you really trying to target as you and Chris were looking at, all right, where do we strategically place these sensors for this UAS traffic management system that we're going to be building?
Yeah, great question. So I don't know if I mentioned this earlier, but Chris and I have actually interacted for a while. So I met Chris back in probably, Chris, 2017 or 18 in Asheville, and we stayed connected over the years. And so I moved from kind of the central part of the state to Winston-Salem, which is where Chris is also home. And so naturally what you do is you start having coffee and spend time with people that are in the same space. And so we started talking, and right around that time he had moved from academia over to TruWeather. And so like you said, Don certainly makes an impression on everybody, and he was part of our integration pilot program, and having him at those workshops to share about weather and the importance of weather was kind of always at the back of my mind. I knew we would need to work with TruWeather at some point, and then having somebody like Chris right here, in the same city, just worked out really well. So we got together and we said, okay, well, you have these great products, but what I need to know is, is there a market for them? Are the operators that want to fly beyond visual line of sight willing to use them? And so we said, okay, well, the only way we can get that is maybe we'll have some workshops as part of our study and invite industry, and let's present these tools that you've created. Let's also share the state of the industry. Let's also have FAA share what they are working on the weather side. And so those are really beneficial. And it marries up really well with our overall focus, which is flying beyond visual line of sight. So we have these other investments in radar and other things, but now that you're flying beyond visual line of sight, you're flying these much longer distances. So right now, for example, we have UPS Flight Forward flying here in Winston-Salem. They're doing drone delivery. The pilot that is on site is able to look around and see what the weather conditions are. They can make those. But do they know what's happening 7 miles away when they want to expand that route, when they be able to fly beyond visual line of sight? Like, the answer is no. And so that was kind of like an aha moment, like, man, we might get this whole system set up where we can detect aircraft and fly drones beyond visual line of sight, and then realize, like, we don't know what's happening there with the weather, and that's going to hinder our advancement. And so that was also, one of the reasons we kicked this study off. So the study really validated that, yes, industry is concerned. Operators, for example, like Duke Energy, the sheriff's office here, who's flying a DFR program, the drone delivery.
That's drone as first responder. I'm sure most of our viewers know that, but for those that don't, I do have some folks that aren't in this industry that watch this show, so I always like to spell out acronyms.
That's great. That's always a good rule. We have tons of acronyms in aviation.
Yes, we do.
And so maybe I'll just quick 10 seconds what drone as first responder is, because I think this is really exciting. So when a 911 call comes in, Forsyth County Sheriff's Office knows where that call is coming from, and they're listening live as that call comes in. And if they hear things that would trigger them to want to send a drone, for example, someone's breaking into my house, someone is following me, you can think of a variety of different reasons, they're going to fly a drone immediately to that site. And that drone often gets there in half the time it takes for a deputy to get there. This is a really, really exciting program that's going to change public safety and law enforcement.
For sure.
So we're excited about that use case. But again, all of those companies kind of validated, yeah, they're really thinking about weather. And some of the things that they are mentioning we had not thought about. Who would have thought there were actually concerns about icing in North Carolina? We heard concerns not just about weather, how it was affecting the flight, but for example, Duke Energy couldn't have fog to be able to see, or really kind of where the light was shining for the sun to see the power line. So there's all these things we learned. And so at the end of the day, we learned that yes, there's a market. They understood what TruWeather services they could apply. And then we did a statewide study, looked back 30 years and said, wow, we have a diverse set of conditions from the coast all the way to the mountains. And we can jump into that if we want as well. So Don, I'll throw that back to you. That was probably more than you bargained for, but there's obviously, you can tell I'm really excited about this study.
No, it's great, and clearly you can see your passion for this as well. What I want to do is, we have a really cool video. I want to roll this now. It talks a little bit about this study and some of the things you were working on together. And I think it'll be a great, number one, visual, but number two, springboard to dive much deeper into this. So let's go ahead and roll that. Great video. And by the way, just shout out to both of you. You know, I think so many people, they'll run headfirst into a situation without really analyzing, no kidding, what is the problem we're trying to solve? And the fact that you looked around and said, you know what, let's do a study first. And I'm sure that had a little bit to do with your academic background, Chris, you know, to determine, you know, what, no kidding, are the needs. You know, what are the gaps in this area that we need to solve? I think really brilliant approach. And so let's talk about, Chris, I'm going to hit you up first. Some of these sensors we saw in that video, you know, some of them look ground-based. Can you just kind of quickly roll us through some of the ones you employed for this study?
Sure. So some of them are ground-based, and they collect information about what is right there where they're located. Some of them are also ground-based, but they have remote sensing technology, which means they can, from a distance away, they can tell what's happening using things like radar, using things like LiDAR, where LiDAR actually sends out a little laser pulse, and then it goes up and sees what kind of dust is scattering laser pulses that it sends back to it. And so with things like that, we can understand what the winds are doing, where the clouds are, and at what height are the winds moving faster, so that we can pull out things like wind shear and wind turbulence. And so we use a variety of these sensors where most of them are ground-based. In fact, we do partner with some folks. Shout out to Meteomatics' Meteodrone, because that's the first commercially available drone, weather drone that we can use to take it up into the atmosphere and see what's happening then and there along that path of the drone flight. And so we even employ something like that when we need to understand even more what's going on in that lower part of the atmosphere. But a lot of the times we use these ground-based sensors to know what's happening right at that point, and then these ground-based but remotely sensing sensors to understand what's happening above us, overhead, and around us.
All right, excellent. Let's see. Okay, we're getting some more comments here. Very nice. Jamie Dyer saying Chris is definitely a problem solver. Nice to see so much expertise at work from everyone to solve such complex and important challenges. So Basil, obviously,
hey, Jamie.
Yeah. So you've got some fans out there, Chris. So Basil, obviously that expertise includes you. So my question is, you know, as you're talking to Chris about where to place these sensors, you know, and we talked about the drone as first responder DFR with the Forsyth County Sheriff's Office. You know, we actually had Tony Smith from Flying Lion on the show I'm going to say it was like August of 2021. By the way, her and Barry Brennan, the CEO of that company, are coming on next month because it's all about data. You know, what they did with Chula Vista PD, who are really, they coined the term DFR. You know, they have, I believe, 4 different locations across Chula Vista on rooftops where, you know, they have like this, I think 3-mile perimeter or so where they can do the DFR, launch those drones from. In your case in North Carolina, whether it's the sheriff's office or you mentioned Duke Energy, are you looking at, for your UAS traffic management or UTM, are you looking at corridors? I mean, you already have, you know, so you've got the sheriff doing DFR, you've got Duke Energy presumably doing some kind of inspections, you've got, you know, Flytrex doing drone deliveries to private homes. I mean, where did you guys determine to place these sensors strategically as you were looking to do this study?
Yeah, great. And appreciate the shout out to Flying Lines. We actually, part of setting up that DFR program, we went out to Chula Vista, and it was gracious for them to host us and show us that entire program. So that was really beneficial. And one of the comments while we're out there, you know, we asked them, well, how often do you have, you know, weather days and you get weathered out? Well, it's southern San Diego, right? It's like, you know, they're like, well, it's always 95% of the year, it's between 60 and 80 degrees. And,
yeah, you wouldn't think they'd have icing problems in California, right?
And sunny. So, and so the comment someone actually made at that time, one of the drone team from North Carolina said, well, we don't have the same, like we're gonna have to think about weather. And so that obviously came to fruition because now we're talking about it and it's an important part of the operation. So you talked about, you know, sensor placement. One of the aha moments for me during this whole process was thinking about the existing sensor placement. So, you know, the AWOS, the automated weather observation system that tells pilots what the weather conditions are at the surface, are located at airports. That makes sense. Take off and land from airports, you're going to want to know where they are or what's happening right there. But you get maybe 3 miles, 5 miles, 7 miles now away from that airport, from where that weather sensor is, and it's not going to tell you, it's not going to be as accurate. And so that's why we need to deploy more sensors elsewhere. And so the study showed actually kind of almost within 5 to 7 miles, just on the other side of the city of Winston-Salem, there was different weather patterns that we saw when we looked at, you know, 30 to 15 years of data. You know, you probably hear people say when you live in an area, oh, we have, you know, here's some weather phenomena. Like, for example, it rains on one side of the city more than it does on the other. And you probably laugh and think, okay, yeah, I'm sure that's true. We actually have data that now shows, wow, that's true. These people were right. Grandmothers were saying, grandparents, yes, this actually is happening. And so that, again, is important because we can't now rely on the weather sensor at the airport. Now, the weather sensor at the airport is really expensive. And so what Chris and
I mean, we're talking hundreds of thousands of dollars, if I recall. You know, I know working with TruWeather, I wrote an article about this, but continue on, yes. Yeah,
it's a great point. It's very expensive. So, for example, the sheriff's office, if they need a weather sensor, they just can't go buy $100,000, right? $200,000 cost and set it up. So what TruWeather is proposing, and they've worked with the ASTM standards to come out with other weather sensors that they can deploy. Maybe they're not $200,000, but they can maybe provide critical information for certain things like temperature, winds, humidity, maybe not visibility. Maybe that'll cost a little bit more money. And so we started looking at this area of operation. And to your point, you were spot on when you said you have multiple operators here. So obviously we want to ensure the sensors that we first place are in these areas where the operators are flying. And so that was kind of how we looked at this space. All right, how close is it to the airport? Where are our operators flying? What are their needs? What are the restrictions to their aircraft? And let's start putting sensors up there to help support them.
Yeah, you know, absolutely. And just thinking about some of these sensors, I'm a huge fan. It was a previously Colorado-based company. They got acquired by a larger company, Animoment. And they have these little baby anemometers. They're like so tiny, and you could put them on a drone, right? So Meteomatics, yes, they've got the Meteo drones, like a flying weather lab, right? But this anemometer, you could just like stick on top of a drone and fly around. So when you think about like law enforcement in particular, you could have real time, data coming out just from that DFR drone that's going out on a response call for a couple $100, I think. That's just from memory again, but I mean, so many cool things out there. So really interesting, Basil, that you're saying in the Winston-Salem area in particular, that you could have rain in one spot and not in another. But you mentioned icing, like, so that maybe raised my eyebrows as well. Like, what are the other kind of weird weather? You mentioned fog. Like, what are the other like interesting weather issues that you're concerned about for ubiquitous drone operations in North Carolina to make sure that you guys have a handle on those?
Yeah, so I knew little to almost nothing about weather as I came into this study, and so of course Chris, Dr. Zarzar, with his academic background, I have been a student of his. He's taught me a lot, so this has been great. And so I'll just mention some things at a high level, and then Chris can jump in here with a little bit more detail. But North Carolina is a large state from coast to mountains, so we really have 3 different regions, and as you can imagine, each region has unique weather characteristics. So the mountain region, we're going to have a lot more, on the western part of our state, close to Tennessee and Kentucky, is going to have a lot more rain. It's probably the wettest part of our state, and it's also going to have a pretty, during the thunderstorm season, there's going to be a lot of flooding that's going to take place. So, and then also there's going to be a lot of fog. So rain is the only area that also gets kind of a lot of snow as well. So there's some really kind of interesting things when we're at higher altitudes. We have mountains that are creating, when wind's blowing over them, unique weather characteristics. There are certainly going to be concerns there for things like DFR programs, drone delivery, et cetera. Now let's just go to the opposite, the far eastern part of our state, the coastal plains. As you can imagine, it's very windy. That's why the Wright brothers came to North Carolina, right? So, and then we have thunderstorms that are going to be pretty much every afternoon on the eastern part of the state. It has a lot to do with the changes in the sea breeze and the hot air that's warming up. And then we go to the middle part of our state, and so we have in the middle part of the state is really where a lot of our population is focused. So what happens is we have these urban centers. Now, urban centers retain more heat, as you can imagine. If you've ever walked barefoot on asphalt or the concrete, it's a lot hotter, and you get onto the grass, right? And the grass is a lot cooler. So just think about that at a macro scale. So we have these cities, and when they retain a lot of heat, they create these weather phenomena. It's called urban heat islands. And so that can create some unique weather situations for operations in that location as well. So again, mountain region, Piedmont region, coastal plain region, each have some unique weather characteristics. Chris, how'd I do?
I'm very proud. I'm very proud of that explanation.
I was going to say, if I could reach out, I'd be patting Chris on the back, because clearly he's an excellent teacher, and you're an incredible student there, Basil. So let me ask you, Chris, because we've got a lot of folks out there, and not everybody's from North Carolina. You have some lessons learned, I imagine, even though there's distinct regions in North Carolina. Some of the things, your findings from this study were specific to that. What could you extrapolate more broadly for the audience that they should be considering for their states or their regions when it comes to low altitude weather?
That is a great question. Before I dive in there, let me say Dr. Jamie Dyer, who gave that last comment, shout out to the research that he's doing down there at Mississippi State University. If you want to talk about some cutting edge drone technology, check out what they do at Mississippi State.
Awesome.
Really cool stuff.
Very cool.
And I'm going to do a couple things here. So yes, I'll talk about what we'll extrapolate, but let me back up really fast and comment on something, because there's a unique thing that relates to this, and that's called microclimates. So just unique conditions based on the characteristics of a place. Currently, I am living about 7 miles from downtown Winston-Salem. 7 miles away from me in downtown Winston-Salem is where Basil is sitting right now. And then about 5 miles from me is where the airport is. And so that's where we have that automated weather observation system. So as I look outside 7 miles away from Basil, I see fog, pretty dense fog. If I look at the AWOS reporting right now, it's saying there's pretty darn good visibility at the airport. And I bet they're in downtown. I look out Basil's window behind him and I don't see any fog there right now. And so we have these microclimates where I'm surrounded by forests and fields, which give that moisture to make for fog. And then Basil's surrounded by this urban area that's a bunch of concrete, not much moisture. And so there's not going to be as high a chance for fog. And so we need to understand this when we talk about these flights beyond visual line of sight, just like Basil said, because we need to know if we're flying somewhere that's going to have fog and could impair our operation, even if we're looking at good conditions where we're taking off and landing.
Absolutely.
And so these are the lessons learned. This is what we find out, because North Carolina, I've always said, is an incredible natural laboratory. We have coastal environments, mountain environments, this Piedmont with urban environments. And so we can take a lot of these lessons learned and move them to the northeastern states, out to the west, understanding how the water interacts with the land, down in the deep south, where we understand how we get this moisture coming on shore. And the big key lesson, though, that we can extrapolate is microclimates. Understanding that there's differences between urban environments when it comes to weather, differences in rural and agricultural environments when it comes to weather, and differences in mountain areas. If you're on top of a mountain, in the valley, if you're on the coast, right on the shoreline, or inland a little bit, there's all these important microclimate characteristics and lessons learned that we can extrapolate to a lot of different environments.
I was going to say, you're preaching to the choir here. I mean, I'm in Colorado, and by the way, shameless plug, I hope someday people will come here and actually fly some drones, but that's a whole different topic for another day. What I'm going to say about it is, I live in Colorado Springs and Monument Hill, they call it a hill, right up the road, much higher elevation, just 5-minute drive. And we can get 3 inches of snow. They can get like half a foot or more, from the same exact event. So, having been in the military in Basil, I was almost laughing out loud when you said in that one spot every afternoon we get thunder showers. I lived in Tampa. I live near Tampa, Florida. And it was like, you better get everything done in any given day, especially in the summer before 2:00, because those thunder showers are rolling in. And I've got a bunch of lacrosse players in my house. You don't want them running around with basically lightning rods on the field. So I feel it, and weather impacts so many things. By the way, Robert Moorhead is out there saying, thanks for the shout out, Chris. So
awesome. Down there in
microclimates, they exist. You proved it. This can be extrapolated, some of the lessons learned, to other places. What else were you going to tell us about that, Chris?
About the weather in the state and the microclimate, how we can move it around.
Yeah, the extrapolation, someone like in Mississippi, why do they care about what you're saying? Like, how is this North Carolina experiment and like workshops and study, how is this important to them and what they're trying to achieve?
Yeah, so let's use that as an example. Talking about Mississippi, they can start to dig in and understand the need for taking that anecdotal information, those experiential events where I'm looking outside and I see fog, and then Basil, he's down there downtown, he's not seeing any fog. What's that mean? What data can we pull, and how can we really understand how far the extent of this challenge is? And so you're going to see similar things if you're in Mississippi and you're in an urban area, or you're just outside an agricultural area. You may have anecdotal experiences where you can say, we get a lot of clouds here. Well, let's bring in the meteorologists. Let's bring in the team and let's understand when, where, and why do those clouds form? Is it a certain time of the day? Where do we need to put the sensors so we can capture that? And we don't have to unnecessarily cancel or delay flights. And we can get more flight time because we know exactly that, in fact, that is a unique microclimate, and we're able to capture it with the strategic deployment of that sensor. And so that is the approach that needs to be taken to capture that information.
Yeah, Robert Moorhead is agreeing here. North Carolina is a good state to test all environments, as Basil noted, because you have mountains, coasts, highly populated areas in flatter terrain. So really, really great stuff. you know, we're not going to, I knew our time was going to fly. Like talking with these two, like that was just a given when we started. We only have 5 minutes left. I want
Oh
to
man.
super briefly, just note that TruWeather has been on the forefront of creating the new weather standard for supplemental data service providers, SDSPs, ASTM 38. Google that, everybody. There is now a weather standard that has been approved. FAA is also looking, I hope, to put that in an advisory circular. I know I've been talking to Don about that. But you guys have also, you guys being TruWeather, and then Chris, I'm going to talk to you. Basil, I'm going to talk to you. You also have been working with air taxis, advanced air mobility, on getting these expedited approvals, if you will, for some of these beyond visual line of sight operations, employing your weather sensors based on some of the safety data you've been able to compile working with other companies, including like this study in North Carolina as an example. So you guys are everywhere. Can you give us a super quick, Chris, projection forward into 2024, where you guys are operating? I know Hampton Roads comes to mind. You've got a big place in Syracuse, obviously North Carolina. You're in the Dallas. Are you working with the Key site down there?
Working with the FAA Dallas Key site. Yep.
Okay.
Yes.
What did I miss?
We've got Utah coming out. We've got some work going on in California, Oregon, Alaska. That's a fun one. So we'll be doing some cool stuff in Alaska there. Let's see. North Dakota is a big one.
Oh,
we're
of course.
doing a lot of cool work in North Dakota.
Yeah, of course.
Yep.
Meteodrone and Grand Sky. Yeah.
Out at Grand Sky, really cool stuff. Yeah, exactly. That's where the Meteodrone's flying. We're learning some really cool lessons about icing out there using the Meteodrone and pulling that data into weather models. Like I said, getting the real data, bringing it into models, improving the system as a whole. So really cool stuff across all those different states and more states each and every day.
Just hard to keep track of, frankly. And Basil, you're firmly rooted in North Carolina, doing great things there. You've got this study now, you know, kind of completed. You've got a lot of lessons learned from this. You've got some money from your legislature. You're going to be setting up this UAS traffic management system. Tell us what we expect to see in 2024 from AeroX in North Carolina.
Yeah, I'll be glad to. I'll just go back and quickly note, just a quick note on, you asked the question, what can other states, you know, glean from this? And one thing everyone takes away from this is the whole industry is moving toward beyond visual line of sight. And when we go beyond visual line of sight, it's not just understanding where other aircraft are flying. It's also understanding what other weather impacts are going to be. And so don't get left behind. Make sure you're focused on weather. So your investments in your sensors, your radar, ADSB, et cetera, that's great. But you got to make sure that you're also thinking about weather, because it's going to sneak up on you and you're going to have to address it. So you might as well have that part of your plan right now. And so for us, you know, fortunately, you know, working with Chris, we're able to kind of come up with a structured plan. And so we're now working closely with FAA, and we're working with TruWeather to identify where are the locations we need to place these sensors to ensure that the operators can use them, provide the feedback to FAA and TruWeather. You talked about that ASTM standard. How can we help FAA, you know, incorporate that standard for approvals? And so in 2024, you should see us turn on the UTM system, the UAS traffic management system, get those radars picking up aircraft, and then start turning on weather sensors as well at the same time. So we're really excited. It's going to be a big year.
Wow. Well, everybody keep your eyes peeled on North Carolina. You know, Basil, I hope you come to our Law Tech Connect workshop. I honestly, now I'm kicking myself because I have a State of the States panel this year at AVSI Exponential. And that's on Monday, April 22nd. You're not on the deck, but you know, we're going to have to do a reprise here because there's so many states doing amazing things. And I'm glad we got to talk about North Carolina here today with TruWeather and AeroX. We're like 1 minute out. So what I want to do is give the floor, you know, each of you 30-second kind of elevator pitch, what you want to leave the audience with. And please, please, please include how they can reach you and learn more about your efforts. So we'll go with you first, Chris, and then we'll end with Basil.
Okay. Don't let weather be the Achilles heel. Basil said it the best. We're going for BV loss. We know we want that beyond visual line of sight. And to be able to unlock the full potential of beyond visual line of sight about operations, we can't let weather be the Achilles heel. And that means real-time data that's strategically deployed, and we know when and where and how to deploy those so we can get the targeted answers for detect and avoid of the weather in addition to detect and avoid of other aircraft.
And how can they reach you or find more information about TruWeather?
You can reach me on LinkedIn. I'm one of the only Chris Zarzars, I think, on LinkedIn, or my email is chriszarzar@trueweathersolutions.com.
Yes, the Z last name always at the end of the line. I didn't get that till I got married. You know, my maiden name is not Zoldai, but all right. So Basil, go ahead. The floor is yours.
Yeah, I'm Y, so I'm just before Z. So you know, in school I was always called last, always at the end of the line. Chris and I know that all too well. So yeah, you know, the takeaway I think for the audience is, you know, we talked a lot about North Carolina, but lots of great states doing things, and we have to have them, and we want to talk to each other, share our lessons learned. So reach out to organizations in your state. You talked about AVSI chapters. Talk about these things. Talk about flying beyond visual line of sight. Talk about weather. What are those hurdles? And really kind of find your community if you're not in North Carolina. But we're also happy to have you as well. So reach out to me. I'm probably the only Basil Yap on LinkedIn, I think. So another unique name there. Or BYAP, that's Bravo Yankee Alpha Papa at NC AeroX, November Charlie, Alpha Echo, Romeo Oscar X-ray.com. So
very nice military letters there. Very impressive, because I spent 25 years in the Air Force and I oftentimes forget what those are. So good for you. All right, everybody, we are a little bit over, but man, what a great show. Thank you both so much. We have just ended a great month dedicated to new tech. You heard about the tech they're employing in North Carolina to solve this low altitude weather, data desert, as Don calls it. So great to have you both on the show. Everybody, we are out here.